Hi, measuring physical quantities is one of the most intriguing things that the physicists would do. For example, the mass of the Earth, the speed of light, and here we would like to talk about the speed of sound. You may say, hey, even the primary secondary school student would know the way that we measure the speed of sound could be done by having maybe a student standing here and then with another student with the known distance, for example, say 100 meter in the sportsgram, and then with a student having something that like a horn which can make a sound, a loud sound obviously, or if you can yell that far, probably not. And then with the flag that you have to indicate the moment where you emit this sound. And then for the student B on the other side, once he or she will see the flag go down, then he or she can start the timer and then stop the timer when B hear the sound. And by that, if you can find the delta t, then you can simply find the speed of sound by the equation of speed equal to 100 divided by delta t, distance over time. Then you can find the speed of sound. But the thing is, this is taking so much effort and you need a friend to help you, and maybe you don't have a friend. So what do? Alright, then you may say you can make use of the idea of reflection, having a wall in front of you, and then you can just do it alone by having maybe putting down a recorder here, which you can record down the waveform, or even oscilloscope, where you can literally display the waveform with the microphone. Then what you can do is you can simply try to clap or again yell whatsoever, make a loud sound, and so the sound wave will be transmitted to the wall and then got reflected backward. And so again, with the known distance d to the wall, then the distance you travel is going to be 2 times d and divided by the time that it takes between the two waveforms. So in your recorder, probably you see something like this and then like this. Alright, so like the two different time, and then you can find the time difference, and again using this you can find the speed of sound. And what if I tell you you can actually measure the speed of sound without going outside? Can you think of an experiment that can find out the speed of sound? Let me give you some hints. First, it must be related to stationary wave. Second, you will need to use a tuning fork and a long tube, and also some water as well. Pause the video and think about it.
A few moments later.
I'm not sure if you could think of the experiment yet. If you don't, go and check out this video with the link below. I have already helped you to set up the starting time, which is around 4 minutes and 40 seconds. And using this, you'll be able to see some loud sound at a certain water level. So go and check out the video.
A few moments later.
So now, the question becomes how we can use just now that experiment. So maybe the information of the position where you have the loud sound to help us measure or estimate the speed of sound. Again, pause the video and think about it.
A few moments later.
Alright, so here is the explanation. When you hear the loud sound, it is because there is a formation of the standing wave. So the first one that you hear is when you have the tube, when you have a certain part of water, so then the effective length is actually the shortest at the beginning. And so in this case, then the formation of the standing wave will be something like this. Okay, so it's a open, one end system where you can form this kind of first harmonic. And when the water go down further, then you probably would have something like this, alright, as the second harmonic. So first, second, and also later on in the video, which probably would be way longer, then you have something like this. Okay, when the water again hit a particular length and again forming the third harmonic. So for example, for the first one, let's say you already measure the length, which is L1, then L1 will equal to a quarter of this standing wave, so 1 over 4 lambda. Same for the second one. If I call this L2, then L2 equal to 3 over 4. If you recall the previous exercise that we did on measuring how many cycles are there. And same for the third one, that will be L3 equal to 5 over 4, of lambda. And so again, since we always know V equals to F lambda, which is the wave equation, very fundamental one, and we already know the frequency, and so if we can simply express the lambda, then we can find it, because lambda is simply from the first equation, that would be 4L1, and so in this case, then we can substitute F and also lambda as 4L1. Then we can find V, because F is known and L1 is known. Or if you can also try to use the second and the third harmonic to help us to triangulate the result, or you can try to plot the graph, that's also fine as well. And so in that case, it will be F, and then this one will be 4 over 3 L2 for lambda, so 4 over 3 L2. And so similarly, you can also use the third harmonic, that is F 5 over, wait, no, it's 4 over 5 L3, right, to find the velocity of, the speed of sound as well. So when we get back to school, you will be the one that doing the experiment, and hopefully you can find out and measure the speed of sound that is very close to the literature value. So now I would like you to try an example on the booklet, which is this one. Pause the video and try it yourself first.
A few moments later.
This example is like the reverse of the experiment that I described, because it tells you the speed of sound and you have to find out the length instead. And so it said that length L is the shortest length that it appears to have a loud sound. That means this is the first harmonic. So the best way of finding it, obviously, like I always say, whenever you're dealing with stationary wave question, draw the diagram. And so for the one that you have here, which is already drawn L, then you should have the first harmonic, which the envelope will be like this. And once again, this L will equal to a quarter of lambda. And so by using the wave equation V equals to F lambda, then you'll be able to substitute 340 from the question and frequency to be 486, and finding out lambda to be about 0.69958 meter, and then you divide by 4 and you can find L. And so eventually the answer will be 0.175 meter. Part B asks you the least distance by which the tube must be raised in order to have another loud sound. So again, that's the next harmonic simply. And so if you could recall the diagram, or you can just draw it by yourself again, the next one is going to look something like this, okay, which a total of 3 over 4 lambda will be of the new length. And so in this case, you can again calculate the new length as in 3 over 4 lambda. So lambda, you can just use the one that you have, because V doesn't change and F doesn't change, right? It's still the same tuning fork that you are using. And so the new length is going to be 0.5246 meter, and then you can minus the length, okay? Or actually, since you know this is 1 over 4 and this is 3 over 4, you can just get the lambda and divide it by 2, because that's the difference of the two lengths. And so the answer is going to be 0.34979 and close to 0.350 meter. So yeah, that is about 35 cm. And so obviously one thing that you can recall is when you choose a different tuning fork, okay, that will affect the frequency, which will affect the wavelength. And so for a different choice of tuning fork, that will affect the distance between the two harmonics. And therefore the tube, you may need to get it to be longer if you choose for a certain tuning fork. And that's some sort of consideration that you need to think about. If your tube is going to be too short, then probably you only get the first harmonic and nothing else. So again, I hope you can appreciate the design and creativity of the experiment and physics concept. You don't have to go out and do those clapping experiment. I mean, those are still good, but then you can also have alternative whenever you do an experiment for physics, trying to find out a physical quantities. This is the beauty of physics. That's all for this video. I hope to see you again in the next video. Bye.